Done?
Yes, sir.
Yes, sir.
So okay. So what is chi-square? Can anybody tell me?
Sir, goodness of fit and value of independence means
It
to
refers
measure.
to statistical hypothesis, right?
Hmm.
So what is hypothesis?
Hypothesis is theorem.
Hypothesis is assumption.
Hy-
Okay. Predetermined assumption. That is called the hypothesis. But when we are telling statistical hypothesis, what does it mean? It means we are inferring the population based upon the sample distribution. Is it clear? So you have the sample data, and based upon the sample data, you are telling the population. You are inferring the population. So when we are inferring the population, then we are dealing with the statistical hypothesis. But if we are not interested for any inference, okay, we want to examine the variation only, then it is not necessary to use the statistical table. Okay, so when you are dealing with the statistical hypothesis, that means whatever the results we'll get, we will get, and based upon that, we can infer the population. So what is the meaning of goodness of fit? This fit means what? Can anybody tell me?
How far it is suitable between the population and the representative of that population.
Okay, that means we have some expectation
Right.
about the distribution. So we are the psychologists. Usually we are expecting the equal probability in the distribution. Okay, so that is our expected. But there are some conditions. There are some subjects, for example, the genetics. Their expected frequency already determined. Okay, so they are testing whether the observed frequencies are matched with the expected frequencies or not. But in psychological research, usually we assume that there will be equal probability. So each individual has equal chance to be selected. So that is called the equal probability. Okay. And another thing, that is any variable will vary across the population. That is the assumption. Okay. For example, age, it varies. Education varies. Socioeconomic status varies. Personality varies. Memory varies. Okay. So variation is there. And we are the psychologists. So we are dealing with the variable. Intelligence is the variable. Memory is the variable. Okay. Therefore, what is important? That is our observed frequencies that will be matched with the expected frequencies. And if it does not match, that means there is some change. Okay. Due to some factor. And we are the psychologists. Our intention is to explore the change, where the change lies, and why the change lies. Is it clear to all of you?
Yes, sir.
Yes, sir.
Okay. Now, Arnold, please, you read what is written.
Like all
Arnold.
yes, sir.
Yes.
Like all hypothesis test, a chi-square goodness of fit test evaluates two hypotheses, the null and alternative hypothesis. There are two competing answers to the question: was the sample drawn from a population that follows the specified distribution? Null hypothesis: the population follows the specified distribution. Alternative hypothesis: the population does not follow the specified distribution. In item analysis of rating scale, equal probability hypothesis is assumed. It means each relative frequency of observed rating category has equal chance to be selected in the relative frequency of expected data distribution.
Okay. So two things are very important in this slide. Number one is the specified distribution. Another one is the equal probability hypothesis. So specified distribution, I have already told, that is, we are psychologists. We are assuming that our variable varies across the population. Okay, so that is our specified distribution, number one. Number two, when we are talking about the distribution, so this distribution, we can think about the normal distribution. Okay. Another important part is the relative frequency. So just to imagine, 5-point rating scale is there. And you have collected data from the 100 people. So it is very much expected that at least 20 data or 20 observations will be there in each category of the response. That means strongly agree will be 20, agree will be 20, undecided will be 20, disagree will be 20, strongly disagree will be 20. If it is not, that means there is individual difference. Okay. So I think the relative frequency is clear to all of you, and probability hypothesis, that is also clear to all of you. Now I am requesting Hashina. Hashina, are you here?
Yes, sir.
Please you read.
Binning, data binning, bucketing is a data pre-processing method used to minimize the effects of small observation errors. The original data values are divided into small intervals known as bins, and then they are replaced by a general value calculated for that bin. This has a smoothing effect on the input data and may also reduce the chances of overfitting in case of small data sets.
So data binning, this is very, very important. When you want to deal with the goodness of it, okay, you may find that is the some observed frequency is very less. Very less means less than 5. So if the observed frequency is less, okay, and the expected frequency is high, then what will happen? Your chi-square value, that will be inflated. Therefore, what is important? You have to merge the data. And during merging, initially you can do this binning. Okay, so data binning, this is very, very important. Specifically when you want to deal with the small observation. Okay, if there is small observation, then you can deal with the data binning. Monica Sri, Monica Sri, please read.
Yes, sir. Current study. Data were collected from customer service representative of one microfinance institution. One liquor type summated rating scale with 5-point rating categories was used to assess achievement motivation level of the CSR. Achievement motivation. It is a motive in connection with evaluated performance in which competition with the standard of excellence was paramount. In microfinance service organizations, CSR people tend to compete in terms of number of customers, clients, and amount of loans. In achievement motivation, we studied career impact, problem solving, hard work, uncertainty, and problem thinking.
Okay. So this is the data on which we are working. Okay, so this data is based upon the summated rating scale, measuring achievement motivation of the customer service representative of one microfinance institution. So when this is the major issue of the applied psychometrics, please you follow. So when we are designing the questionnaire, okay, then the first question comes to our mind. That is how this achievement motivation is related to the job performance of CSR. So it is not like that. That is, there is some achievement test, and I am applying that achievement test here. Okay. Usually you will find the people are doing this type of things. But we are the applied psychometrician, so we know how to design the item. Therefore, we conducted focus group discussion with the CSR. Okay. We administered DAP. You know DAP, draw a person test. Hello,
Yes, sir.
Yes.
draw a person test, you know?
Yes.
Okay.
Yes,
So we
sir.
administered the draw a person test. Okay. And then I have studied their personality pattern. It is not that I have collected some achievement motivation test from some source and I administered it. So that is not the function of the applied psychometrics. Applied psychometrician must be very much aware about the operational definition of the variable, number one. Number two, how the items of the questionnaire will be related to the job responsibilities of the personnel. Is it clear to all of you? So can anybody tell me, that is, instead of this focus group discussion, if I use only one achievement motivation test developed by some other author, if I want to apply that test here, so whether we will face any sort of trouble or not.
Sir, sort of trouble in the sense like we have to, for achievement motivational test, we have to use these things like DAP and all these things, or else for us it will be difficult to get the values.
Yeah, the thing is that suppose one professor of US, okay, and he developed achievement motivation test. And I have applied that achievement motivation test in this condition. There is high chance that some of the items may not be very much applicable in Indian condition, number one. Number two, there is high chance that some items may not be related to their job. Okay. So when the respondents, they will read the item, there will be no cognitive taxation on them. Hasina, what do you mean by the cognitive taxation?
Thought process. Nothing, they cannot relate to the
There
idea.
will be no difficulty. That means the personnel, they can easily relate the item or the statement with their own lifestyle, with their own activities. Okay, so this is a very important area when you want to select the candidate. This is very important. Okay, now, so this is the data set. I think you all have received this data set. So you will find the 9 items are there. Okay, and you will find the frequency distribution. In case of the item 5, one relative frequency is 1. Most of the time you will find, except the item 3. Okay, all the observed frequency is less than 5. So what does it mean? It means that you have to follow merging. Okay, that means if you will use the observed frequency less than 5, and if you merge the data, so the chi-square test for the non-merging and for the merging will be different. Okay, and where the chi-square test will be high and where it will be low. Shara, can you tell?
Not really, sir. I'm still grasping the concept.
Okay.
Sir,
Yeah.
data binning.
Yes. And
Data
Mary,
binning.
data margin, whether the chi-square value for the data margin is low or high in comparison with the data non-merging.
Okay, sir, if the value is less than 5 and the chi-square value is high, then through data binning we can get the observed. Like in small observation, we can use this.
Okay, let's check what happens here. So this is the distribution. Okay, now Priya, please read it. Hello, Priya.
Hello.
Yes,
Am I
Priya,
audible?
please. Yes, you are audible. Please read it.
Yeah, so item 1 is equal to C, bracket 3, comma 11, comma 25, comma 76, comma 94, bracket close. Enter. Chi underscore item 1 is equal to chi square test, bracket item 1. So when we list, then we go ahead with listing chi square item 1 observed and expected and residual values. And then we list chi-square, then chi-square item 1 statistic. So this is the output that we get for that. So in the first one, we can see that we've listed the items that are there. And then I'm guessing we observed values, that's 41.8, 41.8, that's the expected value.
Sure.
Yeah. So
Okay,
3,
Priya.
11, 25,
Hello,
76,
Priya.
and 9.
Okay,
Yeah,
hello,
yeah.
Priya. Here you will find that is this chi item 1. Okay. And chi-square test item 1.
Yeah.
Initially, this chi item 1, it includes the observed frequency. So the observed frequency is 311, 25, 76.
11, 25.
Another one is the expected frequency. That is the 41.8.
41.8.
Another is the residual. Okay. So the chi-square value is 158.63. So here you will find first 3 is less than the expected frequency. Therefore, you will find the residual is minus. Okay. And after that, the observed frequency is higher than the expected frequency. So the residual is positive. The chi-square value is 158.6316. So that is the chi-square value. Is it clear to all of you? So now you open your Art Studio or RPRIT project or mobile, no problem. Just you write down whatever I have written here. Item 1 equal to C, whatever I have written, just you write all of them. If you finish, please you tell me. Hashina, done?
No, sir, still doing. Hello?
Mehdi?
So I'm doing it.
Okay, so you do. If you complete, please you tell done. Done? Madam, have you done it?
Still I'm doing. I couldn't be able to copy it directly.
Okay, I am showing you so that you can follow. Is it visible?
Yes, sir. Yes.
So this is the Art Studio windows are there. Okay.
Yes.
So this is the art script. So if you go to the file, so you file the new file, and after the new file, you can click the art script. Okay, I have already clicked it. So one window file that is created, and I have written whatever the things are in PPT. This is visible to all of you.
Yes, sir.
Okay. So now my function will be to select all of them. Okay. And there is one run command. So I click it. So this is my data. Okay. So whenever I have written, that is the list chi item observed. So that is the chi item. This is the observed frequency. Basically, they are the relative frequencies. Okay. And this is the expected. Here you can find out chi item expected. Chi item is the vector. Item 1 is the vector. What is vector? Vector is the storage, wherein you can store some of the elements. So these are the elements. They are the numbers. They are within this vector. So you have written chi-square test item 1. Okay. And that chi-square test results are chi item 1. And if I write down attributes, bracket, whatever I have written, chi. Chi underscore it comes. Okay. Is it visible to all of you? So this chi item 1, this is a vector. In this vector, you will find all the elements. All the elements you will get. The observed frequency, expected frequency, residual, statistic value, everything you will get. And this is the, for that reason here you can find out the observed value, expected value, residual value, and finally the chi-squared statistics. Is it clear to all of you? Hello.
So this whole content can be pasted in chat box because I'm not able to complete that in my RStudio file.
Huh? What happened?
I'm unable to complete this notes in my RStudio file. So is it possible to paste this particular content in the chat box? So I can
Oh,
use that
acha,
function
acha.
in
Okay,
RStudio.
okay, I understand. Now I can follow. No problem.
Thank you, sir.
That's very good suggestion. Now you can copy and paste and you will get the result. Is it clear now?
Yes, sir.
So what is the result? Arnold? What is the chi-squared value?
Sir, it's 158.6316.
Okay. Now we find that there is one frequency that is less than 5. Okay. Then I am requesting you, so instead of 3,11, you just write down 14, 25, 76, 94. And after that, you compute the chi-square and you tell me what is the chi-square value. Is it clear, Monisha, whatever I am telling?
Yeah, sir, 17. Can you?
Not the 17, because 3 plus 11, 14.
Okay, yeah.
3 plus 11. I have told
Yes,
you, na, that is, you have to merge the data. So,
okay, sir.
so that is the merging.
Can you repeat the numbers just now which you had told, sir?
It will be the, you have written the C bracket
Yes.
3, 11. Na? So
Huh.
instead of the 3, 11, you just write down 14.
Okay. And other numbers are same only.
Same, correct.
Okay.
And then you calculate the chi-square.
It is 86.36842.
Arnold, what is that?
86.36842.
Okay. So Manisha, what is?
Hello.
Yes.
Yes, sir. Mine is also the same. 86.36842.
Okay. Any other done?
Hello?
Yes, Ashina. What is your result?
Yes, sir. I've got the same value. I've got the same value.
Okay, Priya has written, got the same value. So everybody has received the same value. Okay. So when we are dealing with the 3,11, then it is 158. That means the discrepancy very high. Okay, but actually the discrepancy is not very high. Only thing that is we do not have the sufficient observation. For that reason, we are assuming that the discrepancy is very high. Okay, so when you find the high chi-square value, then you always check whether there is any frequency that is relatively very low, maybe less than 5. So whether it is very low or not. If it is low, then your function is to adjust the data through the merging. Is it clear now?
Yes, sir.
So again, whatever the chi-square value, that is significant or not?
Yes, sir, significant.
Okay, since it is significant, that means we can tell that this item, okay, it has the ability to gauge the individual difference. Is it clear now? So in item analysis, our aim is to find out, that is, whether the item is able to measure or is able to gauge the individual differences or not. Okay. And that means individual difference is there. Is it clear or not?
Yes,
Is it
sir.
clear, Pia? Monica Sri, is it clear?
Yes, sir. Yes, sir.
So that is the purpose of the goodness of fit in item analysis. So I think now you can compute the other chi-square. Can you? You can, right?
So this way we can find out the individual difference
Yes,
by
individual.
data
Whether,
binning.
so that is called the data quality. The first quality is whether individual difference is there or not. So now you find that is the individual difference is there. That means you can consider this item for your analysis. So that is the first part. But still, you have to think some more assumptions are there. Now again, in case of the item 2, we find that is the 4, 5, 30, 82, 88. Then what should I do?
Sir, we will merge 4 with 5.
Oh, very good. So that will be the 9.
Sir,
9,
I have a
30,
question.
8.
In
Yes.
item 1, we have 3. So shall we merge with 11?
3 to 11, 3 plus 11, you can merge and then you can get the 14. But
Yes,
here
means
you can find that is a 4, 5. That means 4 is the less than 5. So it is better to merge this data with 5.
It's 9.
okay, sir. Okay, sir. So,
But
sir,
7
one
and
more
8 is
question
there.
I have.
Yes, 7 and 8 is there. Their merging is not required. But in item 4 and others, everywhere merging is required.
Whenever the value is below 5, we have to merge it.
Yes,
Right,
yes.
sir?
This
Means
is
in every item, if there is a value below 5, we have to merge.
merge.
Okay, sir.
This can be done by binning. So we can find out this frequency when there is a continuous data, metric data. So you can find out that is how many categories will be there and what will be the frequencies. For example, here I am presenting you one data set. Is it clear to all of you? So there is a data set, okay, and I have created one vector that is x. X is the vector, and how many data are there? 32 data are there. Okay, so now I am writing hist. H-I-S-T, hist means histogram.
Sir, I have to practice it because I am unable to use in RStudio, but I will surely try for it because I couldn't calculate that in my RStudio.
Hello, madam. Are you telling something?
I am saying I couldn't calculate that in RStudio. I had downloaded RStudio. But today I couldn't complete it. So I will try to complete it.
Okay,
I will
so
require some
I will
clarity.
discuss this issue in the next.
Yes. Sir.
I think that is better. So by this time, because you have already have the knowledge, particularly this, how to deal with the goodness of it through the RStudio. Okay, and you can do the same thing if you have this frequency distribution that you can apply in your mobile, no problem. Okay, but the only thing, there are some advantages when you apply because RStudio, this studio, that is not available in mobile. In mobile, you will get the compiler, but not the RStudio.
So I had downloaded our compiler in mobile. So can I do there also, sir?
Yes.
Okay. Okay. I will check there also because that I able to understand from there.
So, madam, is it possible to show me your mobile, your compiler?
Yes.
If it is, then I can tell you and you can write down. It is very easy. Whatever I have written, na,
Yes.
this item 1 equal to C bracket, then you
Yes,
write
sir,
down
yes.
14 and 25, etc. So you will get the same result.
We did that, I think, last Saturday only. Farah has helped us because I have also the problem related with that.
Okay,
So
okay.
on
Yeah,
our compiler,
Farah
surely
has-
I can do that. Yes, sir, sorry.
Okay,
I-
no
I
problem.
will, yes,
You can
definitely.
do this analysis in your mobile, no problem.
Yes, sir. Sure.
Okay. And you will get these attributes and other things, everything in mobile. I have tested in mobile also. Before teaching, I have tested this data in both laptop as well as mobile,
Right.
so that there will be no conflict. So the students who opted the goodness of fit, this problem, they can do this internship. I have given the format, so please follow the format and prepare your report. Okay?
Okay, sir.
Okay, thank you. Now I want to close the program.
Thank you, sir.
Thank you. Good night. Best wishes to all of you.
Thank you, sir.
Thank you.
Good night. Happy weekend, everyone, including sir.
Thank you.
Thank you, Manisha.
Thank you.
Thank you. Same to you.
Bye. Bye. Good night,
Bye.
everyone.
Bye.